STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Kenneth Harris.
Yay! Welcome to the show, Kenny. How are you today?
Thank you. Thank you. How are you? I'm fantastic.
I'm doing
Great. Thank you for asking.
awesome. So I just want to let everybody know we've got Kenny Harris with us today from the Goddard Space Flight Center, who is actually a satellite engineer. So we are so excited to hear about your work on satellites, including your work with the Webb Telescope. So why don't we just go ahead and get started? Tell us a little bit about yourself.
Yeah, sure. My name's Kenny Harris, born and raised in Maryland, where I still currently live with my wife and my brand new son. He is 9 months old. He's trying to stand now. He's crawling faster than ever and getting into absolutely everything. I work again as a satellite engineer, so really cool stuff in terms of integrating satellites, designing, fabricating them. So I've been with NASA for the past 13 years now. Started when I was 16 years old as an intern in high school, my sophomore year, and we actually started on a program called MMS. Fantastic program, got a lot of good mentors, and then it just snowballed from there. So I'm absolutely excited to be here today and get a chance to talk to you, Jen, specifically about a little bit of my journey.
That is awesome. So a 9-month-old started working at NASA
Yeah.
at 16. Still
Yeah.
there. That says a lot about how much you like your job. Can you tell us a little bit about what it was like to work for NASA in high school? I'm sure that a lot of students out there, our audience, would love to do something like that. How would you get involved in something like
Yes. So prior to getting into NASA, my first year that I was that I had a summer job. Basically, I didn't listen to my mom a lot. I was a knucklehead. She said, "Hey, Kenny, you got to get a summer job." I did not go get a summer job. I ended up actually being a janitor at Bowie High School. So I cleaned lockers, I cleaned desks, I cleaned bathrooms. It was a really, really humbling experience. Really, really, I met some really cool people. Really humbling experience, and it also helped me to understand the pride that I put into my work. So long story short, I ended up working at a spring camp because my younger sister was interested in science and tech and stuff like that. I was there as a camp counselor. And at that camp, I actually met someone from the Goddard Space Flight Center, or another person from the Goddard Space Flight Center. And she said, "Hey, you should apply for this program." Long story short, the following year I applied for the program. I ultimately ended up getting into the program. It's called the High School Internship Program. There were about 25 of us, I think, at the time. It was a relatively small group. And like I said, I worked on MMS doing radiation testing for not only one of the Mars rovers, but also orbiting satellite as well. So extremely cool stuff. And like I said, I got in there just from an internship. And most importantly, something I'll get into later is talking in the networks and being able to converse and have those different conversations with people.
Yeah, so I saw that on your About Me slide. There was a little picture of a person in front of a podium. So is that part of your hobbies? You like to speak to groups?
So I love speaking to groups. I've been doing it again since I was in high school. And this extends beyond just locally. I've also done international stuff. I've spoken in Mexico. I've spoken in Canada as well as Copenhagen. So a lot of different organizations have reached out, just say, "Hey, we'd love to hear what you do, either on James Webb, either on MMS, either on the Mars rover, anything like that." So keynote speaking is something that's been huge for me. It really helps me to get the word out about why science is so cool and why you don't have to be confined to just your desk to have a really, really cool scientific job. And so I guess it is a hobby. It is a hobby, but it's something that I've been doing and something that I'm passionate about as well.
That's great. I love that you're bringing your passion for science out to the general public and definitely to students that are out there. So tell us a little bit about what it was like growing up. classes did you take when you were in high school? Maybe where you went to college, graduation, that kind of thing.
Oh man. Okay. So I see the slide popping up here. I'll start from the left. The left is me as a baby, obviously, or a toddler, I suppose. And there's my dad. He is also an engineer at NASA, and he still works there to this day. So we have never worked on the same project together. It's kind of a unspoken rule we have that well, I've never worked under him, I guess. We worked on the same project before, but it's just an unspoken rule that we won't take on kind of those roles. And now that I'm older, I make the joke to him to say, hey, I won't take on a job that I am your boss or something like that. And so I have spent a lot of my time at NASA since I was a really young child. There's actually a fond memory of when my dad had to pick me and my younger sister up from school one day, and it was late. He works extremely hard. So he was at work and I was tired. So there's a thick piece of foam that was sitting underneath his desk that was left over from a test that they no longer needed at NASA. And I saw the piece of foam and I thought, nap time. So I laid down and took a nap on this piece of foam. And that was like my makeshift bed when I actually was in his office during these late nights. So I'd do homework there. I'd interact with coworkers, anything like that. So that was kind of my upbringing going through NASA. And me and my dad are extremely close. So he knows I love him and all that. In my youth, that picture there is me in my, I want to say second, maybe third internship. I think it was second. Where that picture, the gentleman on the left is Reggie. That's one of my closest friends. And we joined the internship program around the same time. As my lanyard implies, I'm working on the GPM program, which is the Global Precipitation Measurement Satellite. Is the second program I worked on. It's a partner program with JAXA, which is the Japan Aerospace Exploration Agency. Extremely cool. I got another story about them I can probably share later. And that mission there, I got a chance to work on solar array panels as well as deployables. So, when you pack up a satellite and put it into a rocket and send it up, and then it opens up, kind of like a transformer. Not a transformer, but kind of like a transformer, right? So that middle picture there is me in my youth, in my in my high school internship years. Had a lot of experiences there, and Reggie and I are actually still extremely close to this day. He still works at NASA. I actually just left his house earlier today, and so we're still extremely close. And that's part of that building networks, building that those friendships that last a really, really long time. And we also have similar mentors. The farthest picture on the right is me graduating high school with, again, some close friends. We've got our National Honor Society satchels on, and we're excited to be out of high school, right? The gentleman on the far left of that picture, his name is Reese, and I actually ended up going to college with him, and he ended up being my roommate. And we're, again, still close friends to this day. Beyond that high school, after high school, I ended up going to the University of Maryland, Baltimore County, and studying mechanical engineering. Extremely difficult program. I had the time of my life, though. There were times where I doubted myself. There were times that others doubted me as well. But thanks to friends, mentors, having that strong support system, I was able to, again, get through that program. Ultimately graduated, and then ultimately moved on to still have that career at NASA. I did 2 projects while I was in my undergraduate for NASA specifically, and then I ultimately went on to Johns Hopkins University for my master's program. So extremely cool. That's that's the extended version from baby all the way through to master's program, but that's kind of a piece of my journey.
I think there was a lot to unpack there, but I think the major message I got from that was you had a lot of difficulty in school, and yet you pushed on, persevered, not on your own strength, but from help from mentors and your family. And I think it's important for students to hear that you're not alone in your journey. You can always lean on others, right? We had a question that came in. A student named Stardust wanted to know if is there really a giant supermassive black hole in the center of our own Milky Way galaxy? So being a satellite engineer, do you know if that's true or not?
I do not know if that's true. I'm not sure if that's true. I've talked to a number of different people just about the concept of black holes in general. Just recently we got images of the first black hole we've ever seen.
Hmm.
But I do not know anything about this supermassive black hole in the middle of the Milky Way galaxy. I'm sure other smarter folks out there know a lot more about it than I do, but unfortunately, I don't.
Well, you're an engineer, so you're more about putting things together and making
Hands
them
on.
work. I love your analogy of the
Exactly.
Transformer movies. I'm sure a lot of students out there can relate to that, and packing up a satellite
It,
to fit on top of a rocket and then actually work when it gets to space is enough of a challenge.
Jen. Actually, one of the first mentors that I had, he asked me the question of, "Hey, why are you here? Why do you want to be an engineer?" And again, it was during the time where the rebooted Transformer, the Michael Bay Transformers movies come out. So I said, "I'm just here to build a Transformer, basically." It was like, maybe we should think about something a little more realistic. And then he kind of showed me how facets of that movie or facets of the mechanical features of that movie are actually reality in some sorts. And again, that's just kind of how I tied it to my interest in Transformers and comics and drawings and stuff like that, and made it more relatable to what engineers do day to day.
Yep, so there's a little bit of fact in every fiction that you see, right?
Just a little bit.
So I'm a little bit excited because we've got a new segment on our show. Students don't even know this is coming. So we've got, it's called the lightning round. And this is a segment where I'm going to ask you as many questions as I can get through in 30 seconds. And each of these questions, I know, prepare yourself because this is high pressure right
I'm
here.
ready.
All right.
I'm
So
ready.
each of these questions requires just a one um, word answer. And what we're going to do is we're going to create a contest between you and the next subject matter experts that we interview on NASA STEM Stars. So we're going to end up having a leaderboard. But because you're number one, numero uno, you're going to be on the leaderboard already. So we're just going to ask you to watch next week and see if they kick you off the number one spot. How does that sound?
It sounds good. I'm ready. I'm ready. Let's do it.
All right, let's go with this lightning round.
Time for NASA STEM Stars Lightning Round.
All right, let's get 30 seconds on the clock. You're preparing. All right, here we go.
I'm ready.
All right. Early bird or night owl?
Night owl.
Pen or pencil?
Pen.
Comedy or horror?
Comedy.
Introvert or extrovert?
Introvert.
Multiple choice or essay?
Ooh, multiple choice all day.
Tie-dye or bow tie?
Bow tie.
Food truck or restaurant?
Food
Ah!
truck.
And we'll count that one. So
Food
you got
truck.
7 correct. You got
Nice.
7
Food truck.
correct.
Because
So
I love, I love tacos, and the best tacos come from food trucks. So food
you
truck.
know it's street tacos. You got it. So I think that was a lot of fun. What'd you think?
Exactly. Yeah. I loved it. I loved it.
All right. So we got 7 questions correct. So we'll see how next week if you remain the leader on the leaderboard. So fingers
Hopefully I'm
crossed
there for a
that
few
works
weeks.
out for you. So one of my
Oh, yeah.
questions that I was going to ask you was babies or teenagers. So what would you say to that if I was able to get that one in?
I think I'm biased to babies because I have a baby right now. So I think I'm biased to that.
Well, and we were chatting earlier too about middle school students, right? About their,
Yeah.
enthusiasm to learn and ask
Yeah.
questions. So I think I could
Yeah.
go either way on that one. So why
It's
don't
like
you
whenever
tell us a
someone
little
asks me that
about?
question now, it's like whenever someone asks me that question now, because I'm a new dad, I'm programmed to think, do I want a teenager or do I want a baby right now? I'm like, I think that's how my brain is currently programmed.
So just kind of enjoy the moment where you're at.
Exactly. I've heard. I've heard.
So let's go ahead and move into your current career at Goddard. So
Yeah.
that's in Maryland. Why
Yeah.
don't you tell us what your work life
Yeah.
is like?
So my COVID work life is this having these meetings over the internet, over the web, over virtual, this method. But prior to that, had a really cool experience being in the office. You see a lot of pictures there. I'll start in the top left. That is me working on the James Webb Space Telescope. Me and one of my mentors, Matt Stevens, are doing a harness fit check for the electronics component, just basically making sure the harness is long enough that the actual connectors are in the right spot before we actually do the flight integration where we have to sign off on the paperwork and all that fun jazz. Then to the right there, you see me in the full clean room suit, which we affectionately call the bunny suit. And that bunny suit again is a full suit where you can only see kind of this part of my face here. Uh, and that's just a photo of me getting ready to go into the clean room. And we'd spend all day in there. Like, I mean, 8 hours, 6 hours, 7 hours, whatever you want. We leave for lunch and leave for a bathroom break. But for the most part, we were in that room, actually putting together satellites. That's what I mean by integration. So taking each part of the satellite and putting it together. The way I like to explain it is for those that have IKEA or have ever been to IKEA, you get your thing from IKEA, it's got the list of stuff. It's basically that, except a lot more complicated, a lot more people involved, and a lot more money is involved as well. But it's basically doing that. And so now for the image on the bottom left, that picture there is me in front of the James Webb Space Telescope. Again, actually in the clean room, you see that big window behind us. It's called the observation deck, where individuals can, and you see a few people up there, they can come out and they can see the satellite. For this reason, the satellite is actually facing us because, again, we were still integrating it. There came a time, and you'll see a lot of pictures out there that actually have the satellite flipped the other way so people can take a picture of those gold mirrors in the front. And fun fact, the mirrors aren't actually gold. They're just gold plated. They're actually beryllium. And there's some scientific fact behind that, but I won't get into it for this segment. And in bottom right corner there, I am working with one of my close mentors, Steve Cox, at the Goddard Space Flight Center. And that image there is actually me in my 20s. I think I'm 22 there, probably 22, 23 years old there. But I actually met Steve when I was 16 years old. He was one of my very first mentors. And he was one of those folks that was helping me in the radiation department, helping to test different stuff for MMS and for that Mars rover. So we kept that connection strong. I went back to see what he was doing. We worked on a cool project together, and someone snapped a picture of it, and there it is.
Can you explain to the students what a clean room is for those that may not know what that means?
Yeah, so a clean room is an extremely sterile environment that we have to develop satellites in because they're extremely sensitive. Well, the satellite itself might not be extremely sensitive, but the instruments within or on the satellite are sensitive. So I'm talking radars, detectors, cameras, anything like that. We want to make sure that even microscopic particles aren't affecting the data that we can ultimately get. I.e., when we do stuff on James Webb, which the concept of that is we call it the time telescope, to be able to look back in time. Again, a concept I won't get into, but the purpose of it is their infrared sensors and cameras on that satellite are so sensitive that we have to make sure nothing interferes with it prior to its actual run in space. So a clean room is an environment that we use to develop the instruments, and then ultimately integrate the satellite together. And then when the satellite leaves, it's packaged up in this nice container and it's shipped out to wherever it needs to go next, and probably another clean room environment, or it's wrapped up real nice. So it's really for contamination purposes.
So then the bunny suit kind of helps you keep that room clean, right? From the fibers on your clothes to hair. And,
So you'll see we've got the actual hood on for the bunny suit, and then we actually have a mask for those individuals with beards and stuff like that. But really, everyone's required to wear the mask. And you even see our wrists there are taped to make sure that particles that are either on our hands or on our sleeves, on our clothing, don't come off. We keep our shoes on. We have boots that go over top of our boots. We have boots that go over top of our shoes in the clean room. And even there's a little ground strap there as well to make sure that we are grounded when working with electrical systems or anything like that on the satellite. Because again, extremely sensitive stuff we're working with, and usually really expensive stuff we're working with. So it's all a part of making sure everything's good to go when it's in orbit.
We've had some student questions come in while you were talking about work life. Lupe wants to know, are you going to be working on the Venus project?
So I am not working on the Venus project, but I am working on the Artemis generation project for Lunar Gateway, which is actually a smaller version a smaller version of ISS that orbits the moon instead of orbits Earth. So I am involved in projects that are helping us to ultimately study and go to other planets, but not the Venus project, not the Venus project.
All right. Sounds like you're working on a lot of really cool things. We've been talking a lot about Artemis
Yeah,
lately on NASA STEM
sure,
Stars.
sure.
Stardust wants to know, and I don't know if you know the answer to this, but I know we've had some scientists from the Webb group here.
Sure.
How exactly does James Webb Telescope reveal the information at the time of the Big Bang? Because I know you said something about it being called the Time Telescope, and I love that.
Yeah,
So can you just maybe give
sure.
a large picture of maybe an idea of
Yeah.
how that will work?
Yeah, so the concept, I'm gonna pack this into 30 seconds. It's a lot of information in 30 seconds. But the way Webb works, or the way the universe works in general, is when you look up at the night sky and you see a star. You're seeing a star as it was hundreds and thousands and millions of years ago, because it takes time for the light from that star to reach your eye. So the concept behind James Webb is to send it up, deploy it out, point it into the darkness of space, and using the infrared um, imaging systems on board, we plan on looking at the star in the original, and in its original form. So not as it was when it gets to your eye, but looking at it as it was when it is at its source, essentially. And the idea behind it is a concept. It works with a concept or a phenomenon known as red shifting. And again, that's something within the light
Mhm.
spectrum. And you can just Google that, red shifting. Um, and that's kind of the way that we are able to ultimately see back in time, when it's really just seeing the light as it was during that time before it gets to your eye.
Gotcha. I think that'll help them understand a little bit more. It's kind of like looking back in time the deeper you look into space. So
Yeah,
hopefully
yeah,
with
yeah,
Webb we can get
yeah,
some answers.
yeah. And sorry I
Um,
wasn't able to give more. It's just it's so much stuff to say in just that little bit of time.
yeah, and it's not really quite your wheelhouse. So
Yeah,
can you tell us a little bit more about what work life is like on a day-to-day basis, or maybe some things that you've been able
yeah.
to do outside of the clean rooms?
Yeah, so my day-to-day life now is different than it was either pre-COVID or even when I was working on web. I do more project management stuff now, basically meaning I'm more looking at contracts. I'm more looking at how we're going to spin up our new missions, looking at risk assessments. So a lot of paperwork is what I handle now, and I still get to see hardware every now and then. Taking a look at the slides, some of the extra stuff that I'm able and fortunate enough to do. I'll start with the top left. That is our former administrator, Jim Bronstein, and I had the opportunity to meet him following my feature on in the Forbes magazine. Um, and him and I had a great conversation about education and how we're going to impact the next generation, and working on different programs that could ultimately help to get more interns into NASA specifically. And we talked about cool stuff like the Artemis program, going back to the moon. Our shared interest at one time of joining the astronaut corps. He's a great guy to talk to. Then shifting over to the right there, you'll see me
Wait,
in
wait,
front of a
wait,
young
wait.
lady,
You,
and
you just kind of just brushed
glazed over
over
that.
something.
Glazed over
The Forbes
that.
magazine. Wait. Explain the Forbes magazine thing again.
So Forbes has an annual list that comes out. It's called their Forbes 30 under 30, where they pick basically 30 individuals in the U.S. within a specific field that are doing some really cool stuff within their field. So in 2019, 2020, I was on that list for specifically working on James Webb. Again, that satellite is billions of dollars. So a lot of money went into that satellite, and I actually led a few. Where I led the effort to integrate the electronics component to the OTE. So that's just an acronym for basically the large gold mirrors that I pointed out earlier. And I did that when I was 24, 25 years old, one of the two. So it caught the attention. I ended up in the magazine, and Jim called me up like, "Hey, we should talk." And we talked. We had a great time. And now I'd like to consider him a friend. We've talked a few times after that as well.
Sorry, I didn't mean to interrupt. I just needed to dig in a little bit more on that one. So we can go back to the slide now and go over the rest of the pictures that you wanted to share. I was just, wait, Forbes? What? Go ahead.
So let's step back and talk about that. So jumping to the picture in the top right, and it spins into exactly what I was just talking about. That is a news segment, a local news segment that I'm doing with NBC, where they are covering my feature again in Forbes. And we're talking all things James Webb. James Webb. You can kind of see a little bit over her left shoulder behind that light is actually the skeletal structure of James Webb without the mirrors on it. And that well, you can see one in the very bottom left corner of that picture. You can see a little gold plate. There's actually one mirror on that structure for James Webb. And so we're there. We're just talking about James Webb. We're having a good time. I did another interview also where I actually took a correspondent into the clean room staging area and put them in the full bunny suit, and it was an amazing experience. Then the bottom left hand corner there is me on stage at my TED Talk talking about all the cool things I've done at James Webb over my past few years at NASA. I'm again around 20, 25, 26 at the time I'm giving this. So having a really good time talking to students and parents and anyone that was there in the audience. It was a pretty good sized audience as well. Bottom right picture there, you'll see me and a gentleman that kind of sort of looks like me, but just a little bit shorter. I like to make fun of him for that. That's my dad. Like I said, he works at NASA there. We're on different projects, but he was actually featured in that news segment when we talked about James Webb and what it was like being in NASA, what it was like growing up at NASA, and ultimately what it's like having a dad that works for NASA. And so we had a great time. I try to include him in all my outreach stuff because again, it's super cool to have a dad that actually works there and be fortunate enough to be able to share experiences and him be in a similar field than I am.
Well, we actually had a student ask, what is your inspiration? So that might be a segue into what you were just talking about, but what's your inspiration, Kenny?
So my inspiration is my dad. He's been an engineer for as long as I can remember. He went to school for engineering. He worked at another organization for a bit of time when I was really young, and ever since I can formally remember, he's been at NASA though. And I've been fortunate enough to go to launches when I was young. I went to Kennedy. I've gone to Johnson. I've gone to a lot of different NASA centers for either launches or for my own professional work. But just being fortunate enough to have him around and have him, again, in that same field is just super cool to me.
Well, speaking of engineers, I actually want to challenge the students to try their hand at engineering. There's a pretty cool satellite activity that we want to challenge the students to try where they can actually build their own. So you can be like Kenny and try and build your own satellite. We'll put the link in the chat so you can check this activity out. And we definitely want to see the satellites that you built, and we'll definitely share those with Kenny as well. And maybe you can be an intern at NASA in high school based on the work that you've done. Yeah. And also want to encourage you all to tune in next week. Well, it's actually not next week. We're going to take a break for our Independence Day, but we'll be back on July 14th talking about Artemis with Clark Esty. And again, that'll be on Wednesday at 2 o'clock on the 14th. Make sure that you click on that subscribe button and give some thumbs up to Kenny for his awesome work on the lightning round today. And before we leave, everybody, did you want to give the students any last minute thoughts or words of encouragement?
Yeah, I love to leave students with this. The first is just like Sai says, your journey is so much bigger than you. And what I mean by that is everything you do, look to try to inspire someone else that's going to come after you. Encourage them, teach them the lessons that you've learned, and ultimately pour back into them in some way so that they are better prepared to launch the next person into space, to be able to visit another planet, anything like that. Don't keep your knowledge to yourself. And then ultimately make sure that you network. I know a big question that a lot of people ask me is, how do I become an intern? How do I work in NASA? How do I get through these engineering programs? It is your network. You have to know individuals. You have to talk to individuals. You have to make sure that you are well connected, because at the end of the day, I and no one else builds a satellite by themselves. We are constantly working with each other. We are constantly talking, having these meetings, having these dialogues, having these brainstorm sessions so that we can build the absolute most efficient satellite or research product out there. And so with that, I just want to say, just keep it going. You all are each amazing in your own individual ways. I know you do amazing things. Don't forget to give back to others and keep going. You'll definitely make it there.
Thank you so much for that inspirational message. Hopefully students take that to heart. And thank you for spending this quick half hour with us. And hopefully we get to see you again soon. So hopefully we'll see you again in a couple weeks, STEM fans. And thanks for joining us today. Bye, everybody.